Hi everybody and welcome to the 7th video of this series where we make an 8-ball pool game while using only JavaScript and HTML5. In the last video we made the stick reposition itself to the new position of the white ball when all the balls on the table stop moving. We also made it possible to construct balls that have different sprites based on the color argument that we send to their function constructor. Finally, we added all the ball objects to our game world. So here on the canvas, you'll see all the elements we need for our game. And if I'll shoot the ball towards any direction really, as soon as the white ball stops moving, the stick repositions itself to the new position of the white ball. Okay, so there's something that I need to fix before we move on. Now that we have more ball objects, it's not enough to check only if the white ball is moving on the balls moving method. We want to loop over the array and to see if any of the ball objects is moving. So I will set a new boolean balls moving to be false, and let's loop over the array this dot balls dot length I plus plus. And if this dot balls at I is moving, we can set balls moving to be true, and we can break out of the loop. Now we will return balls moving. Back in our browser, let's see that everything still works. Yep, that looks fine. Now in vector2.js, we'll need to add some more operations to support the collision system that we're going to implement later on. So we'll add here a new method. So vector2.prototype.add, and that will be equal a function that will get another vector. And we're just going to return a new vector that will be the sum of both vectors. So this dot x plus vector dot x, and this dot y plus vector dot y. Let's add another one, and let's call this one subtract. And here I will return the subtraction result of the vector argument from this vector. And the last one for now will be the dot product. So vector2.prototype.dot, that will be equal a function that will get another vector, and this function will return the result of a dot product operation between both vectors. So that will be this dot x multiplied by vector dot x plus this dot y multiplied by vector dot y. Now let's go to our game world, and there on the update method, before we do anything, we want to check if collisions occur. So let's write a new method for that, and let's call it on the update method. Let's call this method this.handle collisions. So game world.prototype.handle collisions, and that will be equal a function. And inside this function, I want to loop over the array in a certain manner that will provide me all the possible pairs of objects. So for let I equals 0, I is less than this dot balls dot length, I plus plus, and inside the nested loop, I'm going to declare let j be I plus 1, j is less than this dot balls dot length, I and I plus plus. Okay, so inside this loop, let's get the first ball out of the array. So first ball, that will be equal this dot balls at I, and const second ball, and that will be equal this dot balls at j. And I want to write something like first ball dot collide with second ball. And of course we need to implement this method in order for that to work. Let's see that everything is fine here. Oh, actually I have a mistake inside the nested loop, and we need to increase j, so j++. Okay, so now let's implement the collide with method inside the ball class. So ball.prototype dot collide with, and that will be equal a function that will get a ball as an argument. Okay, so this is the moment we all have been waiting for. Elastic collision in 2 dimensions. And before I begin, I must give a huge credit to Chad Berchek, who wrote an article about this subject in 2009. And this article explains everything in a very simple manner. And even if you don't have a mathematical background, I really encourage you to go and read this article. I will leave a link in the description down below. And really, it's very easy to read, and it explains everything just beautifully. So go and read this article. One more thing that I want to say before we begin is that I'm going to provide you with steps on how to implement elastic collision in your code, but I'm not going to get too deep inside the mathematical proofs and concepts. Okay, so now that we're all set, let's begin. Step 1. Finding a unit normal vector. A unit normal vector is a vector that has length of 1, which is perpendicular to the surfaces of the balls at the point of the collision. In order to find a unit normal vector, we need to find a normal vector first, and we can do that by subtracting one of the ball's position from the other ball's position. So back in our code, in the collide with method, let's find a normal vector. And let's scroll down a little bit so it will be easier to see. Okay, that's better. So const n, and that will be equal this dot position subtract, and we'll send ball dot position. From this normal vector, we can also get the distance between the centers of both balls. And this will indicate us whether a collision occurred or not. So let's find the distance, and let's set const dist to be n dot length. And if the distance is greater than the ball's diameter, then we want to return from this function because there is no collision between both balls. Let's not forget to set another constant that we'll call ball diameter. And in our case, that will be 38. Okay, so now let's find a unit vector of n. And we can do that by taking n and multiplying it by 1 divided by its length. Okay, so now back in our code, let's write a new comment, and we'll declare here that here we're going to find unit normal vector. Let's set const un to be n multiplied by 1 divided by n dot length. Step 2, finding the unit tangent vector. Back to the drawing, you can see that the unit tangent vector is a vector that has a length of 1 and is tangent to the surfaces of the balls at the point of the collision. We can find it by using our unit normal vector that we already found. We just take the x value to be minus un dot y, and the y value of the unit tangent vector to be un dot x. Back in our code, let's write a new comment finding unit tangent vector, and we'll set const ut to be a new vector2 object that its x value will be minus un dot y, and its y value will be un dot x. Step 3. Resolving the velocities into normal and tangential components. So we're doing that by performing a dot product operation between the velocities of the balls and the un and ut vectors that we already found. Back in our code, let's write a comment, project velocities onto the unit normal and unit tangent vectors. Okay, let's go one by one. So const v1n, and that will be equal un dot this dot velocity. Const v1t, and that will be ut dot this dot velocity. Const v2n, and that will be un dot ball dot velocity. And finally const v2t, and that will be equal ut dot ball dot velocity. Step 4. Find new normal velocities. We want to find the normal velocities after the collision, and for that we can use the formula for collisions, for elastic collisions in one dimension. And because both of our objects have the same mass, what we get here is rather simple. If we just put our values inside, we get that v1n tag means after the collision, will be equal to v2n, and v2n tag stands for after the collision, will be equal to v1n that we already calculated in the previous step. So back in our code, that will be pretty easy to implement. So let's just write a new comment first. Find new normal velocities, and we'll set let v1n tag be equals v2n, and let v2n tag be equals v1n. Step 5. Now we want to convert the scalar normal and the tangential velocities into vectors. And for that we need to make some few multiplications between the vectors and the unit normals and the unit tangent that we calculated before. So let's go back to the code and implement that. So back in our code, let's write a new comment, convert the scalar normal and the tangential velocities into vectors. So v1n tag will be the unit normal multiplied by v1n tag, and let's set const v1t tag to be ut multiplied by v1t, and let's set v2n tag to be equal un multiplied by v2n tag, and let's set const v2t tag to be equals the ut multiplied by v2t. Step 6, the final step for now. Update velocities. Now we need to update the velocities of our ball objects according to the equations that you see right here in front of you. So back in our code, let's write a new comment and let's write update velocities. Yeah, finally. So let's set this dot velocity to be v1n tag add v1t tag and ball.velocity to be v2n tag dot add v2t tag. And now let's set this dot moving to be true, and let's also set ball dot moving to be true. Okay, so now back in our browser, let's test the results. I'm really excited. Let's see what happens. Okay. So we do have collisions, but we also have an issue here because you see that the balls kind of merge together, and that's not good for us. There is a way to fix that, and let's do that. Let's fix that. Okay, so back in our code, we will need to find the minimum translation distance, which is the minimum distance that an object, a colliding object, can be moved in order to not collide anymore with the other object. So const minimum translation distance, MTD, will be equal the normal that we calculated before multiplied by the ball diameter minus the distance divided by the distance. And I should put this part in parentheses. Okay, so now let's push and pull the balls apart. Okay, so let's do that by setting this dot position to be this dot position dot add, and I will add the MTD multiplied by half, and I will set ball dot position to be the ball dot position dot subtract MTD multiplied by half. Okay, so back in the browser, let's test the results, and hey, whoa, this is actually working. So let's try another one here. Yay, great. So this was really hard for me to make. I hope you guys like this video, and if you want to watch some more content like this, please subscribe to my channel and stay tuned for more. Thank you very much for watching this, and have a great day. Goodbye.